Okay, here's the function 1 tests, which are basically comparing the RF counter against the SIGGEN, which they're passing, which is good because they were failing. So that means those ICs are good. That's now working. Now on the section 2 tests, we've got some failures. We've got some fail 25, 27. See that? Now basically what section 2 error codes, well, it's not an error code, but the section 2 of the test is basically testing the power meter against the SIGGEN. And if we have a look, we've got 25, 27. There's more down here, but we'll deal with this first. So we look on here, 25 fails low power, 27 fails low power. Basically what it's saying is, on this internal test, the power meter is not getting the readings that it would expect to see from the SIGGEN. And basically what it does, it's part of its routine, it throws up I think it's about 3 or 4 different levels and it would expect to see these levels to be within a certain parameter, and they're not. Now the problem can be 2 things. The problem can either be the power meter or the SIGGEN, because that's what it's testing. You're going between the 2, so you're looking at the power meter against the SIGGEN, so it could be either or. The thing to do, let's just return that. Return. The thing to do is to pop a signal into it, and I can do that quite easily from the SIGGEN. Hang on, let's plug them. Let's plug this, switch this on to TX test. You see, that's now, because we changed the ICs, the frequency counter is now working. It's given us a level of 15.8 milliwatts, which I'm happy with. I don't have a problem with that. The mod frequency is 400 Hz. That's what I've got it set to. At 5 kilohertz deviation. Obviously this is FM, which is 4.99, which is good. Is what I'd expect to see. So I'm happy that that side of it, the power meter's working okay. So I'd say the problem is with the SIGGEN, and most probably to do with the attenuation. Now the easiest way to test this is to literally plug it into a receiver. So I'll do that. Okay, this is now in the receiver test mode, which is basically, it's a signal generator. We've set the frequency to 30 megs. We're injecting a level of minus 78.1 dBm, mod frequency of 1 kilohertz, and a deviation level of 1 kilohertz. Not really worried about that. And we're injecting it into, as you can see, this is a receiver which is set to 30 megs. Now, when I adjust the levels here, see that going up, you know, those clicks, they're just pads, they're attenuators. And each one of these relays, the bulk of them are 10 dB pads. What you'd expect to see is variation, and we're not getting that on the signal strength. Look on the meter. Now if I see, it just jumps up. There's no variable attenuation. So I'm just turning it. You see, every time you hear a click, it's just switching the pad in and out. So, well, this is going to take us to the RF synth board. We'll just go to the circuit. This is the AA4 board. If I'll turn this light on, you might give me a chance to see this. Okay, right. How this works is, there's a lot more going on. This is just one section of the board. Our frequency comes in from the RF gen here, attenuation. We've got these again, the OM345s, two of these, and then that's that IC there. It's just a bad copy. And this is an OM, I can't see what that one is, 370, which is quite a big module. It's got quite a high gain, so it's a 28 dB gain amplifier. But basically what happens is, there's an ALC circuit, it comes down here, it's a little TL071, it's just a precision op amp, and we come down to another operational amplifier here. Now, what happens is we get a voltage variation here, and this is acting as a comparator. So what we need to do is see if there's a voltage, when we adjust the attenuator, then it's expect to see the voltage going up and down to give our variation to our output level, which we're not getting. So we want to test this. That's test point 3. And basically what that does is, you see, it attenuates here. So if you adjust that level there, in theory, you'll be adjusting the output level at this point. Now if there's a problem along this chain, which I suspect, this won't happen. And if that's not happening, we're getting a constant signal, and all we're getting is when the likes of these relays, these pads, switch in and out, we just see a jump in the RF, the RF signal level. Okay, well, let's get the unit opened up and we'll take a look at this test point. Okay, this is the synth board. It's AA4. Now, that's test point 3 there. Now, if I adjust the level, I'm on the scope here, it's set to DC, and you can see we're getting good swing variation there. As we go across to the next pad, that should jump up again. Yep, it does, which is correct. So we know, well, that's good. So we know we're getting a voltage swing. So the problem's in that ALC loop. At some point. Now, we've got, again, OM345s. We know these are notorious, so that's the first place I'm going to have a look. Obviously pin 1 is the input, pin 5 is the output, and we should be seeing gain. Okay, let's take a look. Okay, we're going to test this. The unit's in RX test mode, so there's a signal coming in here. It's 30 megs. It's as good as frequency as any. We'll look at the pin 1, pin 5, that's IC4, pin 1, pin 5 of IC5. So if we look at IC4, it's a bit tricky. Right, that's the input, as you can see. There's a signal there. Let's go on the output of that IC. You can see that. So you can clearly amplify it. We we go pin 1 of IC5. In fact, I'll turn the workshop lights down a bit so you can see the scope. Okay, just bear with me. Okay, that's pin 1 of IC5, which can either be a signal there. That's pin 5 of IC5. That's the output. You can see that's greatly reduced. Again, that's where the problem. Where the problem is. We'll just prove this. There's one other thing we can do. Put the lights back on. One thing I didn't show you. We'll just check the supply voltages to this device. It's that one there that's playing up. I'll change the pair of them, but it's this one here, IC5, that seems to be giving us the problem. But I'll just check the voltages. Okay, I've got the camera on a tripod. Not a very good cameraman, I must admit. Right, pin 4 of this IC is the supply. So set to DC. One is down, one of the negatives down to the chassis. So we should see if the amplifier is getting its control supply voltage. You should see about 12 volts there. He says on pin 4, 11.85. So that's correct. That's what we'd expect to see. So this IC5 clearly is not amplifying. So let's I'll have that out and let's get that replaced. Okay, so IC5, I removed it. I've taken a look on here. That one's working. That shows signs of it's been replaced. I'm going to leave that in, and I'm going to replace. That's the new one to go in here. I had to cut that one up. Again, it was reluctant to come out. Gave it a cesarean. So why do you call it cesarean? Because you have to cut them out. It's probably not very good humour, really. But I'm going to get that in again. You know, pin 1 is there. You know, which should be indicating on the board there. You can see it. Pin 1 is there. Okay, I'm going to get that installed and we'll get it back in the unit and see what we've got. Okay, we've got the new OM modules fitted into the synth board. So let's have a look at the self-test. And remember, when we started this, most of them were failing on the self-test. So let's see how it's performing now. Normal, we're switching the various sections in and out. Here. Oh, they've all passed. So, well, that's good. It means obviously we're moving forward. But if you look at this screen, there's still a fault on here. In transmitter mode, zoom in a touch. That's given us 0.04 milliwatts. That's what he's saying he's reading in power. We'll just switch it over to the onto the 1 watt input. It says it's okay because it's switching different pads in. It's there. And that's a fault. It shouldn't be doing that. Now, there's a number of places this can be. But I don't suspect that you know, it's anything to do with the gen board. It seems to be functioning okay. I have actually run it up. If you have a look at this, get that camera. Look at this 2955 here. So this in there with no input on it, and it's giving 0.00 milliwatts. Okay. Well, there's this board on here. This is the it's AB5. The AB5 board. Has a number of functions, one of which is it's basically where it, you know, it's got the power meter. It basically taps off the IF and comes through some amplification, and you would adjust your, you know, obviously the soft settings as well, but if you wanted to adjust your power meter, you would adjust that pot there, which is R103. But if it's riding up like that, it's not an adjustment. I mean, you know, I mean, if you turn that down and it did go down, which I should imagine it probably will, it should be at 0. So, you know, that's not the problem. Right, let's have a look at the circuit diagram. Okay, this is the AB5. If we get it right. We've got the IF coming in. Obviously, it tees off. It goes off to the other functions down here. Looks like a bit of mixing. Is it there? Let's see that dual gate fit. Anyway, it doesn't matter. Right. Signal path comes up here. Decoupling. There's some filtering happening here. It's an active filter, and it's saying it's a 85k kilohertz low pass filter, and that's obviously to do with this resistor capacitor array. And this is a TL071. Taps off here, goes over to the next page. It comes in here to another opposite, TL 072. It's very similar to the 071, but it's got 2 in 1 package. Yeah, these are very well used op amps. They're very linear to frequency change, and you know, they're reasonably stable. But that's not what we're looking for. That's your power adjustment there. Then goes out to the next page, which is here. And then it comes in and leaves the board, where obviously it goes and you know, it's measured. And we've got these switches here because there's different functions. I think yeah, that's the voltmeter. Comes down. Voltmeter ranging, so that's another parameter. But there, that's what we're interested in. Now, I've done some checking on this. I won't bore you with showing you, but right, on the input of this op amp here, which is IC 101, or part of IC 101, I disconnected this resistor. It's a 22k resistor, and I disconnected it from the board. Just hang on, I'll show you. I've got another one of these boards here. Okay, and if we have a look here, there's your 22k resistor there. That's IC 101. Now I remove that. I've removed that 22k resistor, taken it out of the circuit, fired it up, and the power meter drops back to 0 as it should do. So there's a voltage coming up here when this doesn't appear to have any signal. Now this could be a number of things. This could be something going into self-oscillation. However, we get back to here, it's the IF coming in. What I've done at this stage here is tied. I've just taken this out completely, and this is still happening. I've even tied this to that point to ground, so via that resistor. So I'll just put a link from there to there. It's still there. Now the voltages are present and correct, as they should be, feeding the op amp. There seems to be a voltage in. Now that could either be, this could be taking off, it could be going into self-oscillation, but I seriously doubt that. Could be a problem with these caps, could be. Or it could be a problem with this amplifier. So what I'm going to do, I'm going to remove this out of the board. I'm going to take it out of the equation. There may be a fault here and there's a voltage coming back off the input. There shouldn't really be anything because, coming back up and that's feeding. There's nothing else that feeds it. We've removed the signal at this point, but there's something there. And you can see it. I can see after it's been amplified, we have got a voltage there. It's only but a small voltage, but it's there. And it's constant. So, what I'm going to do, I'm going to pull this out, which is IC100. Okay, well this is IC100. We can see we've removed it. And this is the IC I've taken out here. Now I've removed this. Let's come out. I've removed it using desoldering braid. I use this service hole. It's quite, I can't remember what size that is. 1.5mm. It's called No Clean. It's just at least very let in the way of flux residue. But this is. There's loads of this stuff on the likes of eBay and whatnot. From the I call them the penny bazaars, but everything's 99p. It's generally rubbish. You can't use it. It just you need a good quality. This is expensive. I think this is about 15 quid for 10 metres. I think that's what we pay for it. You've got to use quality gear. You can't use that rubbish off eBay. It's not that there's anything wrong with eBay, but the cheap stuff, you get what you pay for. Right, well that's out. Let's see some residues. I've had the isopropyl in. I'll give that another clean. Look on the other side. See, that's where it's come out there. Just gone over those, and this stuff, I'll tidy it up, but the lacquer comes off these boards. It just falls off. You only got to put a bit of heat near them. So as you can see, but I'll tidy that up. But that's out. And basically, what I'm going to do is put a socket in there. One of these bad boys, and we have these are CPs. I can't remember what CP stands for. I think it's the input voltage saturation point, but you've got different types. And obviously, I can't remember now, but these are obviously dip rather than surface mirror. Okay, that's the IC. So make sure it's in the right way. this gear, all the pin 1s, ICs are all lined up the same way. You know, just one thing to bear in mind if you're changing an IC socket. I don't want to teach you how to suck eggs, but just make sure that if you're putting things on ICs, just make sure it can't affect anything. I remember I did this job on an old summer camp 788DX, and they're a pretty horrible thing to take apart. I changed a load of logic ICs, and I thought, well, I had the bright idea. I thought, well, I'll put them on sockets, because I can, good for plugging things in there. I can test, or, you know, it's just nice to put them on sockets. You know, you can take them out, you can test things, you know, test the points with them not being in situ if there's a problem. But of course, when I put it back together, it was all got it working perfectly. It really took me ages to put it back together, and then it was great. And then I come to put the speaker covers on, and the speaker was catching on the on the ICs because of this raised profile. So out it had to come, and had to go to. It's frustrating. Right, well, that's 102. In this model, this is the AB5, I keep calling it AB5 stroke 1. And on that other board I showed you was a stroke 2, which is a later revision of board. Now, but incidentally, I've had that board in here. It's out of a good, it's not out of this one, it's out of that one. But it works, everything works fine. So, I suspect the problem's going to be here. Well, let's see what happens. Okay, well, we're showing 0 milliwatts is what we're supposed to. So that IC's obviously done the job. It can ride up a little bit. I've not got all the screens on, so, you know, there'll be a bit of noise getting in there. It's vitally important that the screen, you know, the tanks are all set, and obviously I've got off the screws out of the underside tanks. What I'm going to do is I'm going to go through it. Okay, well, I've gone through most of the settings on this. I've still got a bit of performance testing to do on this. Maybe a tad of alignment, but to be honest, actually, it looks in reasonable alignment. I'm going to stop the video here. I've, obviously making videos, repairing equipment makes, it's a lot of work. It's like 3 times as long as actually doing it. But, if there's interest in this video, I'll make a video doing performance testing on one of these. It won't be this one, because this one will be going up to Yorkshire this week, so up to the Cobra Man there, so I'm sure he'll be making a few videos. I hope you enjoyed the messing around that I've been doing with video editors at the beginning of the intro. It's obviously well over the top. I quite enjoy playing around with these things, but it's a bit of fun. It's built up to quite a dull video, really, but hey ho. But let me know if you're interested in, if we go through the performance testing and how these things align. There's also a lot of soft set in these. You've got a lot of, because they don't work in a complete linear fashion across the wide bandwidth. There's electronic, it's software offsets at different ranges in frequency, and you can set all the level readings to suit. It's not something I'd recommend, but the function's there. We could probably have a look at that as well. And obviously one of these units in use as well, which would be interesting. Okay, well, I hope you enjoyed the video, and we hope to catch up with you again soon. This is M0XFX, now going clear.